Let us understand the concept of mean terms and max terms. So these concepts are widely used in all digital applications, students. Whenever we'll be learning the adder, subtractor, multiplexers, your flip-flops, your counters, in many aspects we make use of these mean terms and max terms. But before understanding the detail of this mean term and max terms, so let us try to understand two important formats, that is SOP and POS. Sum of products, which is SOP, product of sum, which is POS, or we say SOP and POS. So generally, any Boolean function, it can be represented in SOP form or in POS form. Although there are several ways to represent Boolean function, but SOP and POS formats are used frequently. So what is the meaning of SOP, students? Sum of products. It means that individual terms are product terms and they are being summed up. So this is a product term, this is a product term, this is a product terms, and they are separated by sum. So we say product terms are being summed up. So we say it is SOP expression. In POS, so individual terms will be sum and they will be producted, which is product of sum. So some terms are being producted is POS and product terms are being summed up. So this is SOP. Okay, I hope there is no confusion in SOP and POS. But in this SOP and POS, again there are two categories. One is known as the standard form and one is known as the canonical form. Okay, one known as standard form, one known as the canonical form. What is the difference between standard and canonical form? So let's say, students, here this f1 is function of 4 variable ABCD. So I'll be telling this is in canonical form if each term is containing all the 4 variable at least once. Not at least once, it should contain exactly once. All the 4 variables should present in every term. For example, if you observe this f3 function, okay, so this is a function of 4 variables. Each term is containing 4 variables. Each term is containing 4 variables. When this is the case, we say it is canonical form. It is just in SOP format, yes. But whether it is canonical, yes. So it is canonical SOP. What is the criteria? Each term should contain all the 4 variables. If the function is of 10 variable, every term should contain all the 10 variable. It could be normal form or complement form. Like here, B is present in complement form. Here, A and D are present in complement form. BC are in normal form. It doesn't matter. But all the variables should present either in normal form or in complement form. Similarly, if you see this one, the function f4, so this is also in canonical form because again it is 4 variable function. And individually, if you see, these are the what? All these are the, what I can say, all these are the containing all the 4 variables. Okay. And in this context, students, we make use of a term known as literal. Okay. So this is a term we use in digital. So what is literal? A variable in its normal or complement form. In its normal, a variable in its normal or complement form is known as literal. Okay. So this is containing 4 literals, this is containing 4 literals, this is containing 4 literals. Okay. So technically sometimes in the books they are writing like every term should contain all the 4 literals. So that is the more specific definitions. Or you can say all variables are present either in normal complement form. The meaning is same. So you understood the definition of canonical, that if the expression not canonical, then it is standard form. So in the standard form, there will be at least one term which is not comprising of all the 4 literals. Like here it is function of A, B, C, D. So here D is missing. Here A and C are missing. Here B is missing. Okay. So every term is not containing all the 4 variables. That's why it is standard. It is the same story for this also. So out of 4, here B is missing, here CD is missing, here A is missing. This is standard form. So here is the definition. In an n variable function, in its corresponding SOP POS representation, if each term contains each of n variables exactly once, complemented or complemented, then the function is said to be in canonical form, else non-canonical form or standard form. So non-canonical form or standard form meaning is same. Okay. I hope you understood this, students. Now let us see what is the definition of mean term and max terms. Remember, students, so to tell it's a to find out the mean term and max term, the given function should be in the canonical form, not in the standard form. So if a given function is in standard form, it is your responsibility to bring that into canonical form and then to access the minterm maxterm data. So how to convert a standard expression into canonical form, that we'll learn later. But let us first understand the definition of minterm and maxterms. So individual term in a canonical SOP is known as minterm. So we have three minterm here. So this minterm, this minterm, this minterm. And individual term in canonical POS is known as maxterms. So each product term in canonical SOP is called minterm. So every term is a minterm. Similarly, each sum term in canonical POS is known as maxterms. And students, while dealing with the truth table, so in the minterm format, variable is treated as 1, variable complement is treated as 0. Similarly, in maxterm, it is opposite. Variable is treated as 0, variable bar is treated as 1. So this is very important. You should not do any kind of confusion on this. The things will be completely changed if you are confused on this. So in minterm, variable is 1, variable complement is 0. In maxterm, variable is 0, variable complement is 1. So what is the meaning of this? Let me take an example of a truth table and let me explain you how to find the minterm maxterm. So initially you need to learn the process. Later on, these all process need not be followed. With experience. Just by look itself, you can tell what are the minterm and maxterm. But initially, let us learn it how it is. So imagine a case that we have this truth table. So this is what is a truth table is. I want to comment its corresponding minterm and maxterms. Okay, minterm and maxterms. So first thing, student, is so while commenting minterm, this is the truth table. Okay, for a digital system, this is the truth table. The inputs are A, B, C, and output is F. So I want to express F in terms of ABC. I have F and F should be expressed in terms of ABC. So let us see. So while commenting minterms, focus those rows where the output is 1. And while commenting maxterm, focus those rows where output is logic 0. So in minterm, your output should be logic 1. In maxterm, you should concentrate those rows where the output is 0. In case if you are given the truth table, from the truth table data you want to find minterm, maxterm. For minterm, you focus those rows where output is 1 and output is 0 means you concentrate this in maxterm. Okay. Now because I am finding minterm, so the row are, this is one row, this is one row, this is one row, and this is one row. So here, students, my area is only these 4 rows. And each row will generate a product terms. And that product term, while dealing with that, so we have to follow this convention. So 1 is treated as variable and 0 is treated as variable bar. So for this one, so here it is 0. So here I'll be writing this is A bar, B bar, C bar. Because 0 means A complement, 0 means variable complement, right? So 0 means A bar, 0 means B bar, 0 means C bar. So from this row, I got this. And then for this row, again, A value is 0. So you get A bar. And B value is 1. So 1 means you should take variable. So it is B. And then C value is 0. You should take, this is C bar. In this row, you see A and B value are 1, 1. So you get A, B, C bar. And the last row, all value are 1. So you should take A, B, C. 1 means variable. So the answer is or combination of this. So for each row we generated a product terms, and because it is sum of products, so we said each term in canonical SOP is the minterm. So I have to find the canonical SOP expression. So these are the individual term and they should be summed up. And if you write it, so this is what the expression you will get. This expression A bar, B bar, C bar plus A bar, B, C bar, then A, B, C bar, and then you have A, B, C. So this is what it is. So from the truth table, this is how we get the corresponding minterm notation. So suppose you want to get the maxterm notation, what will be doing? For maxterms, as I said, you have to concentrate those rows where the output is basically logic 0. So this is a row, this is a row, this is a row, this is a row. So here the output is logic 0. But here students, from each row, earlier you were generating a product term, but here you will be generating a sum term. So what is the term corresponds to this row? You see here 0 should be treated as variable, 1 should be treated as variable bar, and each row will give you a sum term. So here, so A is 0. So I should be writing this is A because 0 is variable, right? So A plus B is 0. So B, C is 1. So 1 means variable complement. It is A plus B plus C bar. And here it is A plus B bar plus C bar because B, C value are 1, 1. In the next row, A is 1. So A is 1 means A bar. B, C are 0, 0. So B plus C. In the next row, A is 1, C is 1. So A bar plus B plus C bar. So from each row you got a sum term, and finally to give the equivalent expression you have to do the AND of these sum terms. So if you check it out, so A plus B plus C bar, A plus B plus C bar, A plus B bar plus C bar, A plus this row, right? A plus B bar plus C bar. Is it the same row or something? No, this is a different expression, students. I mean, this table and this table are not same, so I should not match with this. So anyway, so for this table, if I had have taken, so you have to write this way. So the expression would be A plus B plus C bar ANDed with A plus B bar plus C bar ANDed with A bar plus B plus C ANDed with A bar plus B plus C bar. So this would have been the expression. Okay. So I hope this is clear. Min term means you should concentrate those rows where output is 1. Max term means those rows where the output is 0. So here if you want you can write one more term or one more point. The point is, so here each row will give a product term. But here each row will give sum term. Each row will give the sum term. Okay, fine. But friends, this is fine. So we understood how to write the canonical form from a given truth table. But we want a compact notation. This is absolutely fine what you have done. But imagine a case if you have, like 4 variable or 5 variable. If you have 4 to 5 variables, then the number of terms will be very high. So let's say in a 5 variable case, you have 2 power 5, 32 combination. Out of 32, let's say there are 24 number of combination where the output is 1. Then you have to give an expression which is containing 24 number of term like this. Imagine how lengthy that expression would be. We don't want that. So for that, some alternate representations are being used. Okay, so what is that alternate representation? Let us try to understand. I hope this is clear. So the alternate representation is something like this, students. Very simple actually. Okay, so we understood that the function is this one, right? So this is the function. This is the function, right? Okay. So in this function, students, you see, so first thing is you need to understand it is canonical SOP. Okay, canonical SOP means it is telling us something regarding the mean term, right? Canonical POS means max term, canonical SOP means mean term. So here A bar, B bar, C bar. Okay, A bar, B bar, C bar means what I have to do? So variable complement means you have to take it 0. Variable complement means you have to take it 0. Variable means you have to take it 1. So variable complements are there means it is 0, 0, 0. Here it is. So I am now telling you, so if you have an expression, how to write its corresponding equivalent form. So here it is again A bar means 0, B normal form it is 1, C bar is 0. And here it is A, B normal form 1, 1, C bar means 0. So here it is 1, 1, 1. What is the decimal equivalent of these all binary combinations? It is 0, it is 2, it is 6, it is 7. So this expression which is looking like this, we can write this is Mean term means it is small m is used. And what are this number we got? 0, 2, 6, 7. So this truth table, which is looking like this, so this can be written as simply like 0, 2, 6, 7 with a sum symbol, because we know that. So in the canonical soft, every term are separated by plus. That's why we are using this sum sign. And because mean term, I am using the small m notation, and these numbers are 0 to 6, 7. It is 0 to 6, 7. So we write like this, and this is equivalent to also this way. So what we have understood is, from a given truth table, how to write its canonical soft formats, and from canonical soft format, how to give it shorthand notation. But students, is it necessary to come to this conclusion? You have to do all these things? It's not necessary. Actually, if you use your common sense, you observe the truth table, and I just said in the mean term case, you have to concentrate those where the output is 1. You simply find the decimal equivalent of those combinations. Like here, mean terms are this, and this. So it is 0, 0, 0, 0, 0. So here it is 2, here it is 6, and here it is 7. So 0, 2, 6, 7. Yes or no? 0, 2, 6, 7. So directly you can write like this. Let us do the similar discussion for the Maxterm case. So student, by taking this particular table as reference, I told you how to get the canonical POS expression, which is looking like this. If you do the similar analysis by taking this table, this is what the exact expression you are going to get. So how to get the shorthand notation of this one? So like for this expression, how we got it, we have seen. For this expression, how you get it, we'll see. The shortcut way would be, because in Maxterm case, we are concentrating the output where the output is 0. So in this case, what you can do is, you highlight those rows where the output is 0. So this is a row where output is 0, right? This is a row, output is 0. This is a row, and this is a row. So what are the decimal equivalent of this? I mean, ABC, what are the decimal equivalent of it? 0, 0, 1 is 1. 0, 0, 1 is 1. And then you have, this is 0, 1, 0 is 2. 1, 0, 0 is 4. 1, 1, 0 is 6. So 1, 2, 4, 6. So that's why we can write this as Maxterm M. This is 1, 2, 4, and 6. Maxterm 1, 2, 4, 6. So you see that this can be further written as Maxterm 1 ANDed with Maxterm 2 ANDed with Maxterm 4 ANDed with Maxterm 6. Remember students, in mean term we make use of small m notation. In Maxterm we always make use of capital M notation. Okay, so whenever a question is given, the summation sign and the small m, this is a combination for mean term, and for Maxterm case pi symbol, and this capital M is this one. So this is what it is. So from the truth table, how to write directly, you know, this is very easy. In Minterm case, observe where it is 1, you find the decimal equivalent of those combinations, write those numbers. For Maxterm case, you do the same thing, but by observing the row where output is 0. Okay, and how to get this expression also you have seen. But reverse way also possible. Suppose in a question, this is what is given to you, or this is what is given to you. So what we have done now is, from the truth table, how to reach this we have seen. From the truth table, how to reach this we have seen. But suppose you have this and you have this. In some question, your requirement is from this and this, you have to come to this expression. You can do it or not. Very easy, na? You can easily do it. How you will be doing it? So let's say I know, let's say here it is, this is what is given, and from this I want to reach here. How I will be getting? So from this I can write this one, right? So I know that Maxterm 1 is 0, 0, 1, the binary combination. 2 is 0, 1, 0. 4 is 1, 0, 0. 6 is 1, 1, 0. So in Maxterm case, I know that each number is giving me a sum term. These all are giving me a sum term. So here, so we know like 0, 0, 1. So in case of Maxterm, what we know that 0 means it is variable, 1 means it is variable complement. So 0 means variable. So it is A plus B, 1 means variable complement, C bar. Similarly, A plus B bar plus C. And for 1, 0, 0, how much it will be? It will be A bar plus B plus C, and for 1, 1, 0, it is A plus B plus C bar, like this. Is that no? Same thing you can do for this. So both way you can do. One simple observation I would like you to note here is, in a truth table, those numbers which will come in mean term, they will not come in max terms. Those numbers which will come in max term, they will not come in mean terms. For example, if I say this is my function f1, if I say this is my function f2, so in f1, I can say that a, b, c, the mean terms we have already obtained. Mean terms are 0 to 6, 7. If mean terms are 0 to 6, 7, if I ask you what are the max terms, so I need to concentrate those rows where the output is 0. I mean this row, this row, this row, this row. What is this? This is 1. What is this? This is 3. What is this? This is 4. What is this? This is 5. So 1, 3, 4, 5. So 1, 3, 4, 5. And in F2 of ABC, we obtained the corresponding max terms, and the max terms are how much? 1, 2, 4, 6. Max terms are 1, 2, 4, 6. If max terms are 1, 2, 4, 6, then what are the mean terms? Mean terms, if you check in this case, this is 0, this is 3, this is 5, and this is 7. So 0, 3, 5, 7. 0, 3, 5, 7. So here one important statement we always make use, that mean terms and max terms are mutually exclusive to each other. What is the meaning of it? Those numbers which will come in mean term list, they will not come in max term list, and those which will come in max term list, they won't come in mean term list. Suppose I am saying that 4 is a mean term if a function, that means 4 cannot be a max term. So mean term and max term of same index are always mutually exclusive to each other. So this is the point I have written. Mean term and max terms are always mutually exclusive to each other. So in other words, if a mean terms are given of a function, you can get the max term, or if max terms are given, you can get the mean term. But here I have explained to you by referring the truth table. Now imagine a case, student. So this is the data you have in a 3 variable function. These are the max term. So what are the mean term? So blindly, even without referring the truth table, you can say. So because the numbers are ranging from 0 to 7, out of 0 to 7, these numbers are max terms. So the missing numbers between 0 to 7 will be mean terms. So what are the missing numbers? 0 is missing, 3 is missing, 5 is missing, 7 is missing. These are the mean terms. So mean terms are given, we can get max terms, or max terms are given, we can get the mean terms. In the next video, we are going to see some more property of mean term and max term.